Hey, this is KP the Math G. We are dealing with a volume of solid that is going to be rotated about a line, and in this case we have two equations. Y is equal to x squared. That would be this one, and actually it does not curve back inward like that. It just goes on out like this. Okay, it does not curve back in. Okay, and 4x, y equals 4x minus x squared. It comes up, actually it comes down and crosses at 4. Okay, but it's bounded by these two curves. This is the region that we are wanting to rotate. Alright, this is the region we're under consideration. Okay, and so what we want to do is I'm going to do two more videos. One where I'm taking this same problem for this video and revolve it about y is equal to -2. I just want to set up the problem. I think once you set it up, you can go with that, right? I mean, you know what to do from there. The integrating part is, I want to say, probably easy for you. Hopefully it is. If not, let me know. I'll do one completely. And I have done some completely like this before, but I'll do it again if you ask me to. Okay? But I just want to set them up because this will take time to understand what is going on here. And if you can set them up, I believe you can solve them. Okay, so that is kind of what I decided to do. I didn't do a video yesterday because I was actually working on what I could do to help you understand this concept and then move on. The next idea is to look at some problems from the AP, from prior AP exams. I have one that's been sitting there for at least 3 or 4 weeks now, and it's ready to be presented. So I'm going to do that for a little while probably and get you reviewed up on everything, especially when it's getting time for that test. Okay, so let's go ahead and look at this. Let's start with y is equal to -2. We're going to revolve this. Now remember, our Ives interval, let's get a different color. Our Ives interval is going to be anywhere but right here. We're going to just make it here. Alright, I hope you can see that green alright. Alright, right there. Okay, that's going to be our Ives interval. Okay, let me come up this way here. Alright. The more I do something, I think the worse I make it look. So anyway, that's the idea, and you want your Ives interval to be right there. Alright, and really you're looking at just that region, but we're going to go all the way down to this. Now, and I've done like 3 or 4 videos now on this kind of thing. I think at this point now I'm just ready to just see if you can set them up just for a little bit and understand what is going on. Now remember, this top portion is y is equal to 4x minus x squared, and the bottom portion is y is equal to, this blue is y is equal to x squared. You have to know that. You have to know, and two, you have to be able, in some cases, if they just say rotate the region, it's not going to be mapped out for you like I have it already drawn. Well, it may already be drawn, but they may ask you to find the points of intersection, of which you would have to just say x squared, this y is equal to this y, so x squared is equal to 4x minus x squared. So that may be the first thing that you have to do. Okay, if we add x squared to both sides, okay, add x squared to both sides, this is a 1 and this is a 1, and that makes this 2x squared, and then equals 4x. And then if you bring the 4x to the other side, then you have a minus 4x here and a minus 4x here, and you're left with 2x squared minus 4x is equal to 0. And then of course you would have to solve that, so you can take out a 2x. Alright, you have a common 2 and a common x, so x minus 2. Alright, so 2x equals 0, which means that x is 0, and we already know that. Alright, and then x minus 2 is 0. We can say or in between that. Alright, and then x equals 2. And we know that too just by looking. This point here is 2 comma 4. You can plug it into either one of these. The easiest one is right here. So y is equal to 2 squared, which is 4. So this is 2 comma 4. And for now, that is it's not as important for finding the y value unless you're rotating something around, say, the y-axis or something like that, or a line that's parallel to the y-axis. Okay. Right now, this is y right here. So this distance, let's look at this entire distance. We know how far it is from here to here, and don't say -2. It's the absolute value. You're going down, all right, but you're going down 2 units. Okay, so make sure you understand that. So right here, right here, this distance here is, of course, we know this distance here is 2. All right. How high is this distance from the x-axis to right here? How far is that distance? How far is it from here to here? And if you said y, that's correct. Now, which y are we talking about? Y is 4x minus x squared. Yeah, this is y. So what is this entire distance? Because remember, we got to know the entire distance, because remember, we're rotating it about, I don't have enough board to show that, but about the line y equals -2. So we need to go all the way up from -2 to right here. So how much is this in all? You said this was 2 and this is y, and if you say y plus 2, you are correct. So let's erase all this. Okay, bear with me. I appreciate everyone who's tuning in, and you haven't forgotten about me. I know I haven't forgotten about you. It's just that we've been kind of busy lately, and I've been busy trying to figure out what I can, a better way to show things to you. I always want to try to think about, well, what can I do that's going to make this easy for you to understand this. I almost said my students. If you tune in often, I guess you are my students, and I appreciate that. But if you tune in for the first time, you're still my student. Okay. This thing don't want to stick, so we're just going to put it right here. I don't want to waste time with that. Alright, so let's see. We're saying then, we're doing, remember this is pi r squared, so this is pi, and we'll get the limits of integration in just a moment. Alright, so this big R, it's a big R squared minus a little r squared, and we're going to close that in and say delta x. Remember, this thickness is delta x down here. which we put dx here. Alright, the big radius is this length here, y plus 2. Alright, so let me erase that. And the big R is y plus 2. Alright, so y plus 2, and we're going to square that. Now, we're not going to leave it in terms of y. We're going to write that in terms of x. So what is this y that we're talking about here? Well, it's 4x minus x squared. So let's rewrite this as, let's just rewrite the whole thing, as 4x minus x squared, okay? And then, of course, plus 2, and we're going to square the whole thing. And you can imagine if we squared this, that we're going to have several terms, and that's why I just want to do, just set it up for you. Okay, now that's your first one, y plus 2. That's this y right here that we're talking about. That's the big radius we're talking about. We want to go all the way from -2 to this height here. Okay, that's how you do it. That's just as simple as that. Alright, so y plus 2. Now, remember that in the washer method, we have to subtract off the hollow part, which is right here, down to right here. Okay, we got this hollow from here to here. Alright, so let's figure out what this is. Alright, so how high, we already know this is 2. Well, how high is this? Well, KP the Math G, you already said this was y. Well, yeah, this one's y too, but it's not the same y, is it? This height here, look at it, it touches the blue curve. Well, the blue curve is x squared. Okay, see, this is y is equal to x squared. It tells you what y is. Y is x squared. Alright, so we're going to say x squared plus 2, and then like that, and we're going to close this in, and we're going to put dx. The only thing left to do now is to find our where are we going from and to. Alright, so just keep in mind that this type of interval could go all the way over to 0 and all the way over to 2. You're looking at the x values. This is 0, 0. There's the 0. Limits of integration will be from 0 to 2 then. And I know this was a nightmare for me to figure. I could probably even set this up and not get this. So I had to figure, was it from 0 to 4 or is it from 0 to 2? Well, I'm just kind of thinking I can move that isomorphic interval along the x-axis, see, from 0 to 2. Think about it that way, okay? Alright, there's that problem, okay? 2 plus this y, 2 plus this y here. And that's, well, I got y plus 2, it doesn't matter. Okay, but, I left off something here. I did not square that, did I? Now, remember, everything is squared. And you really and truly, if you're doing this on your calculator, if this is a multiple choice question, or a free response question, not a multiple choice, but a free response rather, then you can just plug this in, if you can keep it all together, and you can get your answer very quickly. Okay? And don't forget to put the pi in your final answer. Alright, there's that one. Alright, so let's do another one, and this time, oh man, I hate wait, I'm going to erase this. So let me erase that. I don't know if I want this. Well, I don't know if I want that or not now. Alright. This time we're going to revolve it. Oh, I might have to erase this too, because I'm doing my offset interval extending, going right through that. Alright, so let's do this. Let's make our offset interval. We want this to go through this line now. B part is y is equal to 5 here, okay? And let's get the green back out. And I am going to leave this here, okay? Let's go all the way up. Okay, all the way up. That's about as crooked as a highway. Some of the highways I've been driving here recently. Okay. Okay. Let's see if I can draw that a little bit. Nah, I don't know if I'm going to draw it any better or not, so I'm just going to leave it. Alright, there's my little interval. Goes down right there. Now, I'll leave all of this here. I'm just going to go ahead and do this, and hopefully this will help you understand. Now, we're revolving it about this, not here, but here. Okay, so let's see what that looks like. I don't know, I may just go ahead and erase this. So let's see. Sometimes it's good to have a little, you know, when I go out to eat out somewhere, I'll take some napkins with me, and that's the reason, so I can use them on my board. Extra napkins, I mean, we grab a few extra, not always on purpose. Okay, now let's see what we get here. Alright. Now, let's see, I had this as y here, okay. Alright, now let's take a look at this one. Well, the easy part is that, okay, we know we are going from 0 to 2 now, okay, that's alright. But now what do we put here? And we know it's going to be a circle. I mean, it's going to be circular, but it's going to be a hole here. See that hole? The hole is right in here, and the solid part is right here. So we're really wanting to go from here to here. All right? Well, let's figure it out. Okay? Let's figure that out. Oh, my goodness, how we figure that out? Well, we're going to figure it out. This offset interval is 5 units long, isn't it? Sure is. So yeah, I keep this down here too. I went below that. I know we need to just go from here up, but I wanted to bring it all the way down. It may help us understand this better. Alright, so let's see. This is the big R right here. From here to here. Let me erase this too. Alright. Alright, from here to here is our big R. From all the way down to there. This we know, well, no, not that high, just down to here. Alright, right there. Okay, I just want to stop there. See that? I don't want to go below this blue line, okay? This blue curve, I want to stay in here, from here. Well, let's see. This whole distance, though, is 5. I'm just going to go ahead and put that there. If I take away that y, this y right here, will I not have the rest of this right here? See, I mean, if this is 1, then 5 minus 1, the rest of this is 4. Okay? Makes sense, doesn't it? So this is y here. I want to take this y away. I want the rest of this right here. I just want this. Okay? So that is 5 minus this blue y right here, this y right here, the blue line, that's x squared, okay? So 5 minus x squared. Square that. And I know I'm subtracting. And I want to tell you something. I want you to learn that I guarantee you there's another 5 minus something in it. Once you see the pattern, that's it. I'm going to have to extend this parentheses a little further out. Now, watch. I'm going to show you something. I want this distance from, okay, got this distance here. I want this distance from here, from the 5 down to right there. That's where the hole is. Okay, that's it right there. I want that distance right there. Well, I know this total distance is 5. Alright, if I could just subtract off this right here, if I could just throw that away, I'd be left with this hole, wouldn't I? That clear section is the hole, y'all. How much is this height right from here to here? Yeah, it's y2, isn't it? But what y is that? Well, that y is this right here. Yeah, you guessed it. But you're going to have to put that, you do not do so well, and then you come up here and you do this right here. You know what's wrong with that. Put a parentheses around it. You got more than one term. Now close that. You're going to square that, and then you're going to put your dx right here. Well, you're going to close it up first. So that's this and this. And I'm going to squeeze that dx right there. Okay, right there. Okay. Alright, so 5 minus this amount is big R. That's y. This y here is 5 minus this part right here, which is up to here on the pink part. Well, that is 4x minus x squared. And then you got it. But you got to remember it's pi r, big R squared minus little r squared. Now you'd have to do a little arithmetic here. Well, okay. Now, yeah, 5 minus x squared. And you're going to square that minus 5 minus. Now you can distribute that. 4x plus x squared. Now square that. Close it up. Delta x, or dx. And that's it. That is your big R squared minus your little r squared. Okay, like that. If you can see that, you study that, believe me. You learn it this way, you can do any revolving anywhere. And so you can guess what my next video is going to be on. It's going to be rotating this way. Alright, so we're going to have our I-sub interval going one way or the other. Okay. Again, I didn't want to work this out. I wasn't looking for an answer. I'm looking for a process. Okay, I'm looking for how do you set this stuff up. I believe you can do the arithmetic, but the calculus part of it is the process of how do I set this up. Okay, and that's what if you learn that, you're learning calculus. Believe me, you got this. And Who said calculus was hard? Yeah, it is. It is. It is. Okay, I know. I know. But anyway, I'm here to try to make this easier for you. I had to learn it. This took a few years to learn this, believe me. But that doesn't mean you cannot learn this in just a little bit of time. If you study this, you got it. Okay, signing off. KP the Math G. Before we sign off, please hit that subscribe button. I've got a few subscribers. I'm loving that. I do. If you want to make a comment, please make a comment and tell me how good of a job I'm doing, or say, hey, KP, there's an easier way. Well, please tell me about it, and it needs to be correct, as I always say, and then I'll present this a better way. I always want a better way. Well, anyway, I appreciate you so much. Believe me, I do. I appreciate you tuning in. I don't get anything out of it. I don't get paid for this. And I'm not asking for money or donations or anything like that. That's not me. I'm just here to help you out. I'm just using my time here, and and then after this, I'm probably going to be busy for the rest of the day. But this is my love. This is my joy. I love doing this, and if I can help you in this way, that's what I want. Okay, KP the Math G signing off. Have a great day.